we are discussing CBSE Standard 12 previous year's physics questions and answer. The chapter belongs to electromagnetic induction and AC, okay, alternating current. So let's resume our discussion. An electron does not suffer deflection while passing through a region of uniform magnetic field. Okay, so what should be the direction of the magnetic field? Now the force experienced by a charged particle, suppose Q is the charged particle, V is the velocity, B is the induction vector of the magnetic field, then this is the force experienced by the charged particle where Q is the charge of the electron, correct? Now what should be the direction of the magnetic field, correct? So this is a cross product of velocity and magnetic induction vector. Now if sine theta, what is V cross B? VB sine theta, where theta is the angle between them. If sine theta is 0, means along the direction of velocity, if the magnetic field exists, okay, both are parallel. If velocity is parallel to the magnetic induction vector, then sine theta will be 0. And if sine theta is 0, then VB sine 0 is 0. So therefore force will be 0. So in order that this force experience is 0, these two should be parallel. Next question. What is eddy currents? Write there two applications. Now question number 2. Figure shows a rectangular conducting loop PQSR. PQSR. This is a rectangular loop in which RS length, okay, this length is movable, okay. The loop is kept in uniform magnetic field, okay, P. How is the magnetic field? Cross means perpendicular to the plane of the paper and it is away from the observer, okay. Okay, so this is the direction of B given, right, downward perpendicular to the plane of the paper. The arm RS is moved with a uniform speed V. Then we have to find the EMF induced across the arm RS, external force required to move the arm, and the power dissipated as heat. Okay, so very good question. So we'll answer one by one. Now what is eddy current? These are the local currents. Okay, eddy currents are the currents induced in bulk pieces of conductors when amount of magnetic flux linked with the conductor changes. So what is this? Because suppose this is a laminated plate. Okay, now the magnetic flux goes through this and it is conducted through this. Okay, this magnetic flux. Now a local current loop gets created which consumes this, dissipate the energy. This is actually overhead. This is actually lost because of eddy currents. So these local current loops are the eddy currents. So eddy current is used in designing deadbeat galvanometer. Okay, and eddy currents is used in deep heat treatment of human body. So these are two applications. Now question number 2, first part. The EMF induced across the arms RS is equal to B into L into V. Okay. So external force required is equal to the EMF induced, the external force required is equal to B into I into L. Okay. So the power dissipated is I square R, where I equal to BLV by R, the resistance. This is EMF. So current is equal to EMF divided by resistance, correct? This is the current. So we have to replace this I square here. So I square R is the, I square RT is the heat generated, I square R is the power. Okay, heat is I square RT, the resistance into the time. So heat dissipated per time is nothing but the power consumed. This is equal to I square into R. So I square into R. So therefore the resistance Okay, now here B square, okay, then this is L square V square by R, this is the power, okay, and R, this is R square and 1 R cancel out, okay, so this is R remaining, this is the power distributed. R is the resistance of the movable arm PQ in the rectangular conductor, okay. Now this is another important question, Lenge's law. Give state Lenge's law, give example to illustrate this law. The Lenge's law is in consequence of the principle of conservation of energy. You have to justify that it is in consequence, it follows the principle of conservation of energy. Deduce expression for mutual inductance of two long coaxial solenoids but having different radii and different number of turns. Okay. So Lenge's law says that what will be the direction of induced EMF when the, suppose this is a closed coil, okay, closed coil means suppose this is the ammeter connected here, okay, galvanometer connected here. Now if we approach a north pole, recedes a north pole, approach a south pole, recedes a south pole, by some way if the magnetic lines of force cutting the plane of the coil be changes, or instead of magnet if we produce a very magnetic lines of force by placing a coil with AC, okay, so this will continuously change the magnetic lines of force, then what should be the direction of EMF induced in the second coil, okay, this is given by the Lenge's law. So direction of induced EMF in another coil because of the very magnetic lines of force cutting the plane of the coil, okay. So it states that the direction will be such that it will oppose the cause due to which it is produced. Suppose north pole is approaching, so it will create here north pole. North pole means direction of current will be such that if north pole is approaching, okay, then the direction of current is like this. This will be the direction of current, correct? If north pole is, if south pole is approaching, then the direction, this is galvanometer, the direction will be like this, correct? Along this, so that south pole will get opposed. So this is Lenge's law. And second part, coaxial coil mutual inductance derivation, we have already done. Next question. If you want to take a screenshot and removing all these things. Okay, let's go to a numerical part of this. Now, in a series LCR circuit, we have two LCR circuit. One is acceptor circuit, other is rejector circuit. Parallel LCR and series LCR, but this is given as series LCR circuit, okay. In a series LCR circuit, the resistance is 100 ohm. L is given as 2 by pi Henry. Capacitance is given as 100 by pi microfarad. The series combination is connected across an AC source of 200 volt and 50 Hz is the frequency, okay. Calculate the total resistance means impedance of the circuit and the peak value of the current flowing in the circuit, okay. Calculate the power factor of the circuit. Compare this value with the one of the resonant frequency. It's very good question. So by solving this numerical, we will also clear our theoretical understanding, okay. So what are given information that we will write first. Resistance is given, coefficient of self-induction L, inductance of this coil is given, and the capacitance is given. So EMF, that is the RMS, is given as 220 volt, okay. Root mean square value of EMF 220 volt and frequency is 50 Hz. Now, what is the inductive reactance? Inductive reactance is equal to XL. XL is omega L. Omega is 2 pi into frequency into L, correct? So it is 2 pi into frequency is 50 and L is 2 by pi, correct? So 200 ohm will be the inductive reactance. Very straightforward question. What is resistance offered by capacitance? This is capacitive reactance 1 by omega c. So it is 1 by omega is 2 pi into frequency, 2 pi f into c. Straightforward, direct, just give these values, you will get XL is 200, XC inductive capacitive reactance is 100 ohm. Impedance of LCR circuit, we have this is LCR circuit and this is the AC connected. We know that total resistance is R square, XL minus XC square. All these things are known. Put it. Okay, this will be 141.4 ohm. Okay, so what is the relation between root mean square EMF and the peak EMF? This is the relation, that the peak value of EMF, the root mean square value of EMF is the peak value of EMF, correct? Peak value of EMF divided by root 2. This we will derive in next question. We have this question. So it is the peak value of EMF is root 2 times the average root mean square EMF, correct? So root 2 times ERMS means 220 into root 2. What is current? Current is equal to V by R, correct? So that is the EMF, maximum current divided by resistance. Resistance means total impedance offered by this LCR circuit, Z. So already we find out that what is Z, okay? So this is 100 root 2, so it is 2.2 ampere. What is power factor? Power factor is cos phi. Cos phi is R by Z, correct? So this is equal to R is 100 by Z is 100 root 2, so it is 1 by root 2 is the power factor. So this is very simple, straightforward, definition based numerical. Next question. Achha, you want to take screenshot? Let me remove it. Okay. Now next, go to next question. Power factor is given R by R. Because at resonance frequency, what is happening? This Z, that is impedance offered by LCR circuit, is R square plus XL minus XC means omega L minus 1 by omega C square. But at resonance frequency, the resistance offered by inductance and capacitance cancel each other. So omega L is equal to 1 by omega C, correct? So these two cancel, so Z equal to only R, okay? And at the time of resonance, the power factor is equal to R by Z, Z is R, so it is 1, correct? Okay. Now, circular coil of radius R carries current I. Write the expression for magnetic field due to the coil at the center of the coil, okay? So it is mu0 by 2 Ni by A, mu0 by 2 Ni by A. This is actually the magnetic field produced at the center. So mu0 by 2 N. Number of turn is not given, so let us assume that number of turn is 1. Okay. mu0 is the permeability, so mu0 into I by 2 into A is the radius. Correct? So you know the current, we know the radius, so we can find out that this is the magnetic field produced at the center of a current carrying coil, at the center, correct? The direction is how to, because if you find the direction also, because magnetic field is a magnetic field vector quantity, you need to show the direction. Now suppose this is the direction of current, okay? Now if you rotate our right hand along the direction of current, so what will be the thumb? Thumb will give this direction, so this will be the direction of magnetic field. If the current is along this, correct? So the magnetic field will be directed towards this, perpendicular to the plane of the coil and towards the left hand side, okay? So this question answered. Now, why do we say that a places like Delhi and Mumbai A magnetic needle shows the true north direction quite accurately as compared to the other places. Okay. The declination is greater at higher latitudes and smaller near the equator. The declination in India is small, it being 0 degree and 41 minute east at Delhi and 0 degree 58 minute west at Mumbai. Thus, at both these places, a magnetic needle shows the true north quite accurately. Okay. Define coefficient of mutual induction. Write the essay on it. This is already answered. Mutual inductance derivation of two coaxial solenoids. This already we have answered. Let's do this. Distinguish between the terms average value of and RMS value in alternating current. See, in alternating current we know that the current and the EMF both changes with respect to time, correct? Now, so what is average value? Suppose this is my E is equal to our EP sin omega t, the induced EMF. I is equal to IP sin omega t, the current in this circuit. Okay. Now, since it is on alternating current, alternating EMF, so it is continuously changing. No? From 0 to T by 2, okay, and then T by 2 to T. Now, if we want to represent it in the average format, what is the average current flowing, and if we take the sum from 0 to T by 2, then this will give the average, correct? We cannot take the sum of average of all the instantaneous current up to 0 to T, because if we take from 0 to T, then what will happen? 0 to T by 2 current is positive, 0 to T by 2 to T current is negative. So if we sum up all the instantaneous current over 0 to T, okay, to get the average, it will become 0, correct? Because same whatever thing is in the positive direction, same thing is in the negative direction. So we cannot take the average current by summing up all the instantaneous currents over the entire full cycle, correct? So in order to represent the average current, we take the sum of values from 0 to T by 2, half cycle. So this is called average. So what is half cycle? Okay, so let us do I. Okay, I is the current. Now let us sum it up, summation of I. Okay, so how to summation up I? It is integration. Integration with respect to what is varying? With respect to time, dt. Okay, so now from what to what will be the initial time, what is the final time? 0 to T by 2. Okay, like in average mean, you add all these observations and then divided by the number of observations. Here you have added from 0 to T by 2, so you have to divide it also by T by 2. This particular value is called the average current, correct? This is I average. In this question you have to find out the average current. Had it been average EMF, okay, same thing, E integration of dt over 0 to T by 2. Since you have added up to 0 to T by 2, you have to divide by T by 2. This is average EMF, okay, average EMF. Now what is I? I is equal to IP sin omega t, or I0 sin omega t. Peak value of current can be represented by I is equal to I0 sin omega t, whereas I is the peak value, correct? So now integration of sin omega t is minus cos omega t. Now put the upper limit T by 2, put the lower limit. Ultimately we get average current is equal to 2I0 by pi. Okay, similarly, same way, E is equal to EP sin omega t, E0 sin omega t. In place of I, we will have only E. So the E average will be how much? 2 into peak value divided by pi. Okay, now in this question, EP is given as, E0 is given as 5 and omega is given as 314. What is the average and RMS value of current? Now I will explain what is RMS. RMS means Now instead of taking the average of half cycle, we want to take the average of full cycle. So all the negative to be made positive. So that is what, to find the RMS, let us calculate what is RMS value of current and RMS value of EMF. Suppose I want to take the average over the entire cycle. So what is my first trick? I will make all the instantaneous EMF positive. How it is can be made positive? We can square it up, correct? And then we can sum it up. Taking sum means integration from what to what? From 0 to the entire cycle. T is entire cycle, okay, T. Now since we have taken 0 to T time, okay, similar to our normal statistical average, we have to divide it by T, correct? Now initially we had squared all this instantaneous EMF to get rid of negative, correct? So this will give us the average square. So in order to get rid of square, we have to take the square root, correct? That is why it is called E root. This is the root. Mean means added up to T and divided by T, mean, and squared all the instantaneous EMF. Yes. So this is the expression of ERMS, correct? Squared it, add it, divided by it by the same time interval, and then take the square root, because initially we have squared, correct? This is ERMS. So same thing in place of, or similarly IRMS, the root mean square value of, this is actually true representation of average current, average EMF. This will be how much? Square the instantaneous current and add it up to 0 to T interval, okay, divide it by T and take the square root. This is IRMS. Now it is simply the integration part, where in place of I you have to put I0 sin omega t, correct, I, and integrate it, okay, and in place of E you have to put E0 sin omega t. This is the value of E, and then integrate. Just the entire thing is a mathematical integration only, correct? So let's do it. So this is integration of sin square omega t, okay? So now 2 sin square omega t is 1 minus cos 2 omega t. There is a beautiful formula for this. When it is a square and we have to convert it, like, just remember one thing: cos square omega t minus sin square omega t equal to cos 2 omega t. This is the formula. Now since you have sin square omega t, convert this cos square omega t to 1 minus sin square omega t minus sin square omega t equal to cos 2 omega t. Okay, this is the trick. Just remember one thing: you can do anything from square to multiple angles conversion. So this is 1 minus 2 sin square omega t equal to cos 2 omega t. Instead, suppose if you can't remember this formula, then only you need to do it. Okay, so 1 minus cos 2 omega t equal to 2 sin square omega t. So 1 minus cos 2 omega t, 2 comes here. Okay, so 2 is coming here. This is sin square omega t. So this is represented by the sin square, 2 sin square omega t is written as 1 minus cos 2 omega t, and then integration of cos 2 omega t, that we know already, that it is sin 2 omega t by 2 omega, 2 omega is multiple, and then put the values. Okay, now here in this numerical, that the equation given is I is equal to I0 sin omega t. So I0 is straightforward, peak value of current 5 ampere given, omega is given as 314. So average is equal to how much? I is equal to this is the average current, 0.6, okay, and RMS is actually the RMS value of, if we up to this much we have done, correct? Okay, so this comes out once we put the limit here 0 to t. Okay, now what will happen? So ERMS square equal to EP square by 2t. If you put t here, omega is 2 pi by t and upper limit is t written, so it is sine 2 pi, sine 2 pi is 0, this is also 0, so this entire term cancel out. Okay, so nothing is there, tt cancel out, so it is e p square by 2. Okay, so only t remains, so it is, so e RMS is nothing but square root of this much, ep square by 2, so ep by root 2, correct. So just see, the average is equal to 2 ep by pi, and average E average is equal to 2 ep by pi, and okay, and E RMS is ep by root 2. So average is equal to 2 into average current is same thing, average current equal to 2 into ip by pi, correct. So ip is given, divided by pi you find out, so you get this much. Average is by root 2, ep by root 2. Okay, so this much will get it. So now it is very easy to answer. Okay, now this question. Explain with the help of level diagram the underlying principle working of a step-up transformer. That we have already explained. Step-up means the voltage of the secondary is more than primary, number of turns should be more than the secondary, correct. Why we cannot use DC? Because in DC voltage is not changing, flux will not changing, electromagnetic index will not happen. Okay. Now, this question. Given two electric circuits A and B. Okay, this is circuit A, this is circuit B. Okay, calculate the ratio of power factor of the circuit B to the power factor of the circuit A. So it is XL means inductive reactance is 3R and ohmic resistance is R. And in this circuit, inductive resistance is 3R and there is a capacitor involved here R. Okay, so we have to find out the power factor. Okay, let's do it. Now in the first circuit we do not have capacitive reactance, so it is R square plus XL square is the total impedance, correct, and the power factor is R by total impedance, so this is the 1 by root 2. In the second circuit we have both LCR circuit, so total impedance is this, put these values, cos phi is equal to R by total impedance, so everything is given here, so 1 by root 5. So therefore the power factor of B by power factor of A is root 10 by root 5, it is not 2. Okay. The vertical component of Earth's magnetic field is root 2 times the horizontal component. Okay, find the angle of D. See, this is the terrestrial magnetism, this is the magnetic field BT. So the horizontal component is BH. Okay. So if delta is the angle of dip, then BH is how much? BH is equal to BT cos delta, correct? And what is BB? The vertical component. Vertical component is BT sin delta. Okay. So tan delta is equal to BB by BH, correct? Tan delta is BB by BH root 2. So tan delta is root 3 means what? Delta is 60 degree. So angle of dip can be found. So we did experiment in our classroom how to find angle of dip using dip circle. So there you do all these things, okay, bringing it to magnetic meridian, then find the angle of dip. Now principle of cyclotron we have already explained. Two uses of this machine. It is used actually cyclotron is used to produce high energetic charge particle. Okay. So it is this high energetic charge particle is to bombard. Okay, so bombardment. So cyclotron is used to bombard nuclei with energetic particles and study the resulting nuclear reactions. This is number one use. Second, this is used in hospital to produce radioactive substances used for diagnosis. Correct. Okay. Mutual inductance of the power of the coil. Okay. Now, how is the mutual inductance of a pair of coil affected when separation between the coil increased? Okay, very good question. Now this will give you clear understanding whether you understood mutual inductance or not. the number of turns in each coil increased. Okay. Thin iron sheet is placed between the two coils. Automatically it will carry more magnetic lines of force and the flux leakage will be reduced. Okay. Other factors remaining the same, means number of coils, distance same, only what you have done, only one more permeable material is introduced between the coil. Answer is now. First, when the separation of the two coils increase, the flux linked with the secondary due to the current in the primary decreases, because see, the concentration of magnetic flux is more near the magnetic field where it is produced. Here the concentration is more. As we move, the concentration decreases. So if the separation between the two coils increased, these two increase, the flux will be less dense here in the secondary coil. So as a result, less magnetic lines of force will cut the plane of the secondary coil, hence the mutual inductance decreases. First part is very clear. Second, number of turns. Okay, now the mutual inductance increases when the number of turns increases, correct? More EMF will be used. So it is okay, because M is directly proportional to the product of the number of turns in the primary and secondary. So if you increase it, then mutual inductance will increase. Now, when you place a ferromagnetic material like iron, the flux leakage will be less, otherwise flux leakage will be there here, correct? So more lines of force will cut and be conducted from primary to secondary. So when iron sheet is placed, the coil's mutual inductance increases because it is directly proportional to the permeability. Okay, this is a very good question. Now, given the given circuit diagram shows LCA circuit connected to a variable frequency 230 volt source. Okay, let us see the given. L is given, so C is given, so you can find out. Okay, radian per second. Now at resonance, Z is equal to R, the 40 ohm. This is resonance frequency, correct? So omega L is equal to omega L is equal to omega C. This is the condition for resonance. Wait, let me write this thing. Omega C. So omega L is equal to XL is equal to XC. Means resistance offered by inductance is resistance offered by the capacitor. So XL is omega L, XC is omega 1 by omega C. So omega square is equal to LC. So omega is equal to how much? 1 by root over LC. So this is what is given, resonance frequency. At resonance, since both these cancel out, these two, so only the impedance in the circuit is the resistance R. We have inductance 5 Henry is the 5 Henry is inductance, capacitance 80 microfarad and 40 ohm is the resistance. Determine the source frequency. So what is source frequency? Which drives the circuit in resonance. So at resonance what happens? At resonance XL is equal to XC. So XL is omega L, XC is 1 by omega C. So omega square is equal to 1 by LC. So omega is equal to 1 by root over LC, correct? So this 50 radian. Okay. At resonance the only impedance is the ohmic resistance, which is 40 ohm. Current amplitude is equal to voltage divided by the total resistance. Okay. And voltage, how to find out voltage? The Vrms is how much? V by root 2. So root 2 times the RMS is equal to the voltage. So root 2 times RMS is voltage by R, 8.1 ampere. Current is Vrms by R, 230 is given already by 40, because across the resistance current is same. The potential drop across inductance is equal to current into the resistance offered by inductance. Potential difference across the capacitance is equal to the current into capacitive reactance, the resistance offered by capacitor 1 by omega C. At resonant frequency it is omega R, correct? So this we can find out. Potential difference across the resistance is current into resistance. Okay. Now how do you explain across the three? Okay. Now how do you explain the observation that the algebraic sum of voltages across the three elements obtained is greater than the supplied voltage? See, if we add all this potential drop, means VL, VC and VR, correct, and VR. Now this will not give the total potential difference, correct, because that is VL and VC, they are not in phase, okay, not in phase with current. So VL is leading the current. If current is along this, then VR will be along this. Potential difference across resistance, VL will be along y-axis because potential drop leads the current, and VC, potential drop lags the current. VC will be along this. So these two difference will give VL minus VC. Suppose this is VL minus VC. So it is a vector thing, na? So algebraic sum will not give. This is VL minus VC and this is VR. So how to get the resultant? This is square, okay? Law of parallelogram of vectors. So this is V. So what is V? V is actual V is VR square plus VL minus VC square, correct? So that is why the sum of algebraic thing of all this individual component potential difference will not give rise to the total potential difference. That is clear. So Vrms is the applied RMS voltage. Okay, now next question. The primary coil of an ideal step-up transformer is 100 turns. Transformation ratio means the ratio of the turns is also 100. Okay. The input voltage and the power is 220 and 1100 watt. Calculate number of turns and all these things. Now see, we have this, that the transformation ratio is number of turn in the secondary by number of turn in the primary, correct? So this we can find out the number of turn in the secondary. Similarly, the power is equal to current into voltage, correct? So the current will be power divided by voltage. This can be obtained, correct? Voltage across the secondary. Voltage across secondary is Vs by Vp. Vs by Vp is equal to the transformation ratio. So Vs is equal to Vp into transformation ratio. Power across secondary is power across primary because transformation ratio is 100%. So this current across secondary is power divided by voltage, 0.5 ampere, correct? Okay. Now next question. Electron is projected along the direction of x-axis. Okay. This is the velocity. Magnetic force is experienced along y-axis. Okay. So this is the force experienced. Then you have to find out the magnetic field is applied in which direction. Obviously, the force is perpendicular to the plane containing the magnetic field and velocity. So obviously it should be in the z direction. Then only it will experience the force along y-axis. Clear? Lenge's law we have explained. Magnetic declination means angle of dip we know. Okay. This already we know. When the magnet moves towards the right hand will develop the south polarity and left of this coil, and left of the coil develop south polarity, and the left end of the coil also develops south polarity. Okay, why? Because suppose there is a magnet here, okay, and there are two coils. Suppose this is one coil 1 and this is another coil 2. Okay, now suppose when the magnet moves towards south, the right end of the coil develops south polarity. Okay, suppose this is south is moving, not this. Okay, this will develop south polarity because as per Lenge's law it will oppose the movement approaching south pole. So south pole to be developed, correct? Similarly, when the magnet is moving towards the right, the north pole is receding. North pole is going away from this coil, correct? Left hand coil. So it will try to attract the north pole, that is the opposition. It will keep it attracted. So therefore, how to attract north pole if south pole is developed? So when a magnet is moved towards the right of two closed coils, okay, then both the coil means the south pole will the right hand as well as the left hand both develop the south polarity. Correct? Now draw the graph showing variation of inductive reactance and capacitive reactance with frequency applied in AC. Okay. So can the voltage drop across inductor capacitors in series LCS circuit be greater than that of the applied voltage in AC source? Justify your answer. Okay. So first of all the graph. Okay. So this is Xi minus frequency and this is XL minus frequency, because see what will happen in the capacitive reactance means Xc is 1 by omega c, 2 pi f into c. So if the frequency increases, the capacitance decreases, the resistance offered by capacitors will decrease, but the inductive impedance, inductive reactance is equal to omega L, it is 2 pi into f into L. So if f increases, then XL also increases. Okay, next. Yes, this is possible. The voltage drop across the inductor or the capacitors in the series LCS circuit can be greater than the applied voltage. These two voltages are not in the same phase. Okay, it is AC circuit. So the current and potential drop are not in phase. Hence, they cannot be added like ordinary numbers. That we have already explained in earlier example. Now explain with the help of diagram the principle of working of AC generator. We have already explained. Write the expression of EMF generated by a coil in terms of speed and separation. That we have already done. So this actually completes our electromagnetic induction and AC. Okay, so next class we will discuss about the most important topic is electromagnetic waves. Okay, so we will resume our discussion. Here we will solve all the previous year's questions of CBSE Standard 12 related to EM waves. Thank you very much.